All right, we are ready to start tackling solving exponential equations. So if you read it below, it says we will first learn to solve exponential equations of the form a to the u power is equal to a to the v power. We will solve more complex exponential equations in section 6.6. Okay, so basically when you encounter an exponential equation, it's going to be an equation. Okay, so it's going to be a statement with an equal sign, and the variable that you're solving for is in the power or exponent. Okay, there are simple exponential equations. Okay, that's what we're going to start with. And then we're going to work our way up to solving more complicated exponential equations in a later section. Okay, again, to start, we're starting with these simple exponential equations, and they look like this. A to the u power is equal to a to the v power. Okay, so notice in this statement, okay, you've got an equation, you've got an equal sign, and on either side of the equal sign, you've got something exponential, you've got something raised to a power. The base on both sides is the same. Okay, so the base is a on the left side and the base is a on the right side. Okay, so basically, to solve something like this, it says when two exponential expressions with the same base are equal, then their exponents are equal. Okay, so it's summarized in the box. If you see the statement that a to the u power is equal to a to the v power, the only way that can be true, since the bases are the same, that means that u has to equal v. The exponents or the powers have to be equal. Okay, all right, so going on to example 4, we are going to do several of these for practice. Okay, so like I said, these are going to be pretty simple. Okay, you're going to have to use the laws of exponents. Okay, eventually we will work our way up by the end of the semester to solving more complicated exponential equations. Okay, so example 4, solve each equation. All right, in part A, the equation is 5 to the x is equal to 5 to the negative 6 power. Okay, so when you look at this, okay, we've got an equation, we've got an equal sign. On the left side, we have 5 to the x power. On the right side, we have 5 to the negative 6 power. So basically, what you see is that the base is the same on both sides. Okay, it's 5 to some power on both sides of the equation. Okay, so the only way you're trying to solve this for x, you want to know what power or what value of x makes this a true statement. Okay, since you have 5 to a power on one side and 5 to a power on the other side, since the bases are both 5, the only way this can be a true statement is if the exponents are equal, the powers. Okay, so this tells us that x, the power on the left, has to equal the power on the right, which is negative 6. That's it. You're done. Okay, solved the equation. Okay, the answer has to be x has to be negative 6 to make that a true statement. Okay, that's what we're doing here. Okay, you're trying to have a situation where the base on the left side is equal to the base on the right side, and then you just equate the exponents. All right, let's look at part B. It's not as straightforward. You have 3 to the negative x power is equal to 81. Okay, again, you're trying to figure out what value of x is going to make this a true statement. Okay, in part A, it was nice because you could clearly see the base was 5 on the left side and 5 on the right side. Here it's different because the base on the left side is 3. 3 is what's being raised to the power. On the right, the base is 81 because 81 is raised to the first power. Okay, so you can't just say, oh, I'm going to equate the exponents. You can't do that because the bases are different. Okay, what you have to do here is you have to make the bases the same. Okay, and to do that, it is easier to transform the bigger number into the smaller number. Okay, so if you look at the two bases, I have 3 and 81. Okay, 3 is the smaller number, so I'm going to keep it. Okay, I'm not going to make any changes to the left side because I'm keeping the base at 3. Okay, so on the right side, I need to rewrite 81 as 3 to a power. Okay, so let's think about this. 3 times 3 is 9, times 3 is 27. times 3 is 81. So 3 to the fourth is the same thing as 81. Okay, so what I'm going to do is rewrite the right side. Okay, 81 is the same thing as 3 to the fourth. Okay, you have to do this. These two quantities in yellow are equal. 3 to the fourth is the same thing as 81. Okay, now I have the same base on both sides. Okay, the left side is 3 to a power, the right side is 3 to a power. Since the bases are the same, the only way the two sides can be equal is if the power on the left is equal to the power on the right. So we come up with the conclusion that negative x is equal to 4. Okay, we are solving for x, okay, not negative x. So to get rid of the negative sign in front, we've got to divide both sides by -1. Okay, and this tells us that the answer is x is equal to -4. Okay, and we're done. We've solved the equation. Okay, this is the value of x that is going to make this a true statement. The great thing about solving equations is you can check yourself. Okay, if you take your x value and you plug it into the original statement, see if you get a true statement. Okay, so watch. Okay, if I go to my calculator, I'm going to type in 3 to the negative x, but I'm going to use x is -4. Okay, so let me actually write it out here. Okay, if I'm checking myself, I'm doing 3 to the negative x. Okay, so that's going to be 3 to the negative. This is this negative sign right here. Okay, and then x is -4. Okay, so basically what happens here is you're going to get 3 to the +4 because the two negative signs cancel. And actually, we don't even need the calculator here. This is going to be 3 times 3 times 3 times 3. Okay, 3 times 3 is 9, times 3 is 27, times 3 is 81. We get a true statement. Okay, so always check yourself if you can. Okay, you'll at least know if you're right or wrong. All right, let's look at the next exponential equation. Okay, this one's a bit tricky, okay, because it is a fraction. Okay, let's see what we can do here. On the left, we have 1/4 raised to the x power, and then on the right, we just have 1/64. Okay, again, we're trying to figure out what value of x makes this true. Okay, it's exponential because x is in the power or the exponent. Okay, so there's actually a couple of different ways you can do this. I think the easiest way here, okay, we've talked about this in this section already. If you have a fraction raised to a power like you do on the left side, you're allowed to take the numerator and raise it to the power, and then take the denominator and raise it to the power. Okay, so I'm going to start by doing that on the left. I'm going to raise 1 to the x power and then raise 4 to the x power. That has to equal 1/64. Again, we're trying to figure out what power of x makes this a true statement. Okay, and then in the next step, 1 to the x power. 1 to any power is 1. Okay, that's one of those laws of exponents. Okay, so I've got 1/4x is equal to 1/64. Okay, all right, so now let's look at this. Okay, we have two fractions. Okay, the numerators are the same. Okay, both numerators are 1. Okay, so the only way these two fractions can be equal is if 4 to the x is equal to 64. The denominators have to be equal. Okay, so we need to know, when is 4 to the x equal to 64? Okay, all right, well, now we can try to get the bases to be the same. Okay, on the left side, I have a base of 4, so I'm going to keep it. Remember, it's easier to change the bigger number into the smaller number. Okay, so I need to rewrite 64 as a power of 4. Okay, so let's think about it. Okay, I'm going to go over here. 4 times 4 is 16, times 4 is 64. Okay, 4 times 4 is 16, times 4 is 64. Okay, so 64 is the same thing as 4 to the third power. So if I come over here, okay, 64 is the same thing as 4 to the third power. 64 is the same thing as 4 to the third power. Okay, now I have a power of 4 equal to a power of 4. The only way that can be true is if the exponents are equal. Okay, so you equate and you get that the x value that works here is 3. Okay, that's what makes this a true statement. Okay, again, you can check yourself, and you should. If you take 1/4, okay, the left side here, and raise it to the third power, that's what we got for x. This means you're taking 1/4 and multiplying it by itself 3 times. Okay, to multiply fractions, you multiply across the top. 1 times 1 times 1 is 1, and then you multiply across the bottom. 4 times 4 times 4 is 64, and that is the right side. Okay, so we are correct. Okay, always check yourself if you can. Okay, moving on to part D. Okay, all right, we have 5 to the x plus 3 power. We want to know, when is that equal to 1/5? Okay, so we've got a fraction involved, and fractions are always tricky. Okay, I want to work with base 5. Okay, you see a 5 on both sides. Okay, let's leave the left side alone. Okay, and here's a trick. Okay, I can do something to the right side here. 1/5 is the same thing as 5 to the negative 1 power. Okay, so let me go over that. Okay, so if you have 5 to the negative 1, okay, remember, we don't think in terms of negative exponents. So we can get rid of the negative exponent if we do 1 over the quantity, but then we change the sign of the exponent. Okay, so we get 1/5. Okay, 1/5 is the same thing as 5 to the negative 1 power. Okay, you may have to do this from time to time. Okay, 2 to the negative 1 is going to be 1/2. 3 to the negative 1 is going to be 1/3. 4 to the negative 1 is going to be 1/4. 5 to the negative 1 is 1/5. 6 to the negative 1 is 1/6, and so on. Okay, that is a very nifty trick to know. Okay, so 1/5 is the same thing as 5 to the negative 1. Okay, and now that is great because on the left side I have a power of 5, and on the right side I have a power of 5. The only way these two things can be equal is if the exponents are equal. Okay, so once the bases are equal, you set the exponents equal to each other. So we're going to get x plus 3 is equal to negative 1. Okay, and then we solve for x. Okay, so we're going to subtract 3 from both sides, and we get that the x value that makes this a true statement is negative 4, and we're done. Okay, again, you can and should check yourself. Okay, if we are checking ourselves, go back to the original statement, plug in x equals negative 4. We're going to get 5 to the negative 4 plus 3. We're trying to see if that equals 1/5. So this is going to be 5 to the negative 1, and that is indeed 1/5. Okay, all right. Let's go down here. We've got more. Okay, all right.